Welcome back to the Science and Slumber, the quiet corner of the cosmos where we explore the universe's greatest wonders, one slow breath at a time. Tonight, we're going on a slow, soothing journey, not outward to the distant stars, but downward, deep into the earth beneath our feet, deep into the quiet library of stone and time. We are here to ask a gentle question. What if the story of intelligent life on this planet has more than one chapter? What if we are not the first? It sounds simple, a tale of science fiction, but the deeper you fall into this idea, the more profound it becomes. It asks us to quiet our sense of the present and listen for a possible echo from a past so impossibly deep, it has been almost entirely erased. If you have a quiet moment, a simple tap on the like button, and maybe a soft click to subscribe, helps this sleepy little channel grow and reach others who might be looking for a place like this. For now, though, just settle in, get comfortable. There is nothing you need to do, nothing to remember. Let your body feel heavy and warm. Let the words wash over you, like fine layers of dust settling in a still and ancient room, each one a whisper from a forgotten year. Our journey begins not with a discovery, but with a question, a thought experiment with a wonderfully strange name. This quiet question, this gentle thought experiment, is known as the Silurian Hypothesis. The name itself is whimsical, borrowed from a classic episode of the television show Doctor Who, but the idea it represents comes from a place of deep and serious scientific curiosity. It wasn't born from a sudden discovery of a strange fossil or an impossible ruin, but from a quiet conversation between two brilliant minds trying to understand our own place in the planet's long, slow story. Imagine an astrophysicist, Adam Frank, who spends his life looking up at the countless stars, wondering if other civilizations exist out there. Now imagine a climatologist, Gavin Schmidt, the director of NASA's Goddard Institute for Space Studies, who spends his life looking down, studying the intricate systems of our own world. One day, their perspectives met in the middle. They asked, when we look for intelligent life in the universe, we search for its effects on a planet's atmosphere. Could we use those very same tools to look for intelligent life in our own planet's deep past? The name Silurian refers to a fictional race of intelligent reptiles in the show, who are said to have existed in Earth's Silurian period, over 400 million years ago. Frank and Schmidt chose this name with a smile, to make it clear that this is not a claim that lizard people once roamed the Earth. It is not a theory. It is, instead, a tool for thinking. It is a way of asking, if an industrial civilization like our own had existed millions of years before us, what kind of trace would it have left behind? And, more importantly, would we even be able to recognize it? Think of the Silurian hypothesis not as a map to a buried treasure, but as a tuning fork. Imagine holding one in your hand now, the cool, smooth weight of the steel, the elegant, two-pronged shape designed for a single purpose, to listen for a specific resonance. A tuning fork is silent until you strike it. The question, what if we are not the first, is the gentle tap that makes it vibrate. And once it is humming with that quiet energy, you don't hold it up to a violin or a piano, you hold it up to the earth itself. You press its base against a vast wall of ancient rock, a cliff face with layers of sediment stacked like the pages of a forgotten book, and you listen. You are not listening for a shout, or a song, or the echo of a voice. You are listening for a faint, sympathetic hum, a deep vibration in the stone that tells you something in the distant past was once tuned to the same frequency as you are now. In other words, the hypothesis is a beautiful inversion of our usual to search. It suggests that the clearest signs of a civilization might not be a statue's hand or a shard of pottery. The most enduring legacy might not be a pyramid, but a subtle change in the chemistry of the air and oceans, captured and fossilized in layers of mud that turn to rock. What this really means is that we must learn to look for a ghost. Not the ghost of a person, but the ghost of an entire global system, its energy, its waste, its footprint, a faint chemical shadow left on the planet's memory. It's a profound shift in thinking. It tells us that to find evidence of a mind, we shouldn't look for a skull, we should look for the traces of its global impact. This is not a simple task. We are searching for a story written in a language we are only just beginning to understand. The forces of time are immense, patient, and relentless. They crush mountains into dust and turn continents into seabeds. A span of a few million years is more than enough to bury, melt, and recycle almost every trace of a civilization's physical presence. So, before we can even begin to look for a single lost word from a forgotten chapter of Earth's history, we must first come to understand the book in which it was written. We must appreciate the immense and quiet nature of the geological archive itself. To truly understand the scale of our search, we must first picture the archive where the evidence would be kept. Imagine you are standing at the entrance to a library, but this library is unlike any you have ever seen. It is not made of wood or stone, but of time itself. Its shelves are the stratified layers of rock that make up the Earth's crust, and its books are the fossils and chemical signatures pressed between those layers. This is the geological record, the planet's own slow, patient memory. As you step inside, there is no grand foyer, only a deep, profound stillness. The air is cool and smells of ancient dust and damp earth. There is no electric light, only a soft, diffuse glow that seems to come from the rocks themselves, as if they hold the faint memory of 1 billion sunsets. The library's collection is vast, stretching back not for centuries, but for over 4 billion years. Each step you take down its long, silent corridors carries you 1 million years into the past. The layers of rock beneath your feet are like the pages of a book, each one preserving a snapshot of a world that no longer exists. A thin, dark band of shale might be a chapter about a shallow, muddy sea filled with tiny, shelled creatures. A thick layer of sandstone, the colour of pale honey, might tell the story of a vast desert where winds sculpted dunes for 100,000 years. The colours shift and swirl around you, reds and ochres from iron-rich soils, deep charcoals from ancient compressed swamps, and soft, chalky whites from the skeletal remains of trillions of microscopic plankton that once drifted in a forgotten ocean. But this library has been subject to the slow, relentless forces of nature. It is not a pristine, climate-controlled archive. Imagine that. Over the eons, there have been fires, floods, and earthquakes. Entire wings of the library have collapsed. Continents have drifted apart, tearing sections of the collection in two. Other sections have been pushed deep into the Earth's mantle, where the intense heat and pressure have melted them down, their stories erased like books thrown into a furnace. What remains is not a complete history, but a collection of fragments. There are vast gaps in the narrative, entire epochs for which we have only a few scattered pages, or sometimes none at all. What this really means is that the geological record is not a perfect history. It is a story of survivors. Only the most durable materials, preserved under the most perfect and improbable conditions, make it onto the shelves. A creature living in a calm, shallow sea, where sediment gently rains down to cover its body, has a chance of becoming a fossil. Its story might be preserved. But a creature living on a high mountain, exposed to wind and rain, will almost certainly erode into nothingness. Its chapter is lost forever. There's something quietly humbling about this idea. It tells us that our planet is not designed to remember, it is designed to forget. Its natural state is one of constant recycling and renewal. To preserve a memory in the rock is the exception, not the rule. So, when we ask if we can find the story of a lost industrial civilization, we are not just looking for a misplaced book. We are looking for a story that was written on pages that were never meant to last, in a library that is constantly, quietly dismantling itself. The vast majority of all life that has ever existed on Earth has vanished without a trace. No bones, no shells, no footprints, just silence. So, if the book of life itself is so fragmented, what hope do we have of finding the specific, delicate, and complex artifacts of a civilization? To grasp this challenge, we must move from the grand scale of the library to the intimate scale of a single fragile object. We must imagine not just a book, but a work of art, something built with purpose and left to the mercies of time. We need to picture a sandcastle, standing alone on the shore as the tide begins to turn. Imagine yourself on a vast, empty beach at twilight. The sun has just dipped below the horizon, and the sky is a soft gradient of violet and rose. The air is cool and still, and the only sound is the gentle rhythmic sigh of the waves, washing in and out. Before you stands a magnificent sandcastle. It is not a simple bucket and spade creation, but a complex city in miniature. There are towers and ramparts, delicate archways and intricate staircases carved into the damp sand. It is a testament to an afternoon of focused, creative energy. For a fleeting moment, it is a civilization. It has structure, form, and purpose. It is a tiny, beautiful anomaly on the edge of a wild and powerful ocean. Now, just sit and watch. You don't have to do anything. Just observe as the patient, inexorable forces of nature begin their quiet work. The tide is coming in. The first wave sends a thin, foamy finger of water gliding up the beach. It reaches the outer walls of the castle and then recedes, taking with it a few loose grains of sand. It seems like nothing. A moment later, another wave, a little stronger this time, washes over the foundations. The sharp edges of the ramparts begin to soften. A small outer tower, its base undercut by the water, slumps and dissolves back into the formless sand. The process is not violent or dramatic. It is a slow, gentle erasure. As the minutes turn into an hour, the water rises higher. The waves are no longer just touching the castle. They are embracing it, pulling it back into the sea from which it came. The beautiful archways collapse. The intricate staircases become smooth, sloping ramps. The entire city is sagging, losing its definition, its memory of being anything other than a mound of wet sand. By the time the moon is high in the sky, casting a silver path across the water, the sandcastle is gone. Not just broken, but completely gone. The sand has been smoothed over by the tide, and there is no sign that anything was ever there. The beach looks as if it has been untouched for 1,000 years. This is what happens to a civilization's direct evidence over geological time, but on an impossibly larger and slower scale. The sandcastle represents the cities, the statues, the roads, the machines, everything a society builds. The waves are the forces of erosion, weathering, and decay. The wind, the rain, the ice, the slow chemical reactions in the soil, they are the patient tide, working tirelessly for millions of years. But the analogy goes deeper. The very ground on which the sandcastle was built is not permanent. The beach itself is in motion. This is the process of plate tectonics. The Earth's crust is a collection of massive plates, floating and moving on a sea of molten rock. Continents collide, raising up mountain ranges. They pull apart, creating new oceans. Sections of the crust are constantly being pulled down into the Earth's mantle, in a process called subduction, where they are melted and recycled. What this really means is that even if a civilization's cities were made of solid granite instead of sand, the land they were built upon might have been dragged down into the Earth's fiery interior and completely remade. A city in a coastal region today might be at the bottom of the deep ocean in 10 million years. A mountain range might be ground down into a flat plain. Over 100 million years, the entire surface of our planet is relentlessly resurfaced. There's something so profound in this realization. It means that the Earth has no permanent memory on its surface. It is a canvas that is constantly being painted over. So, the direct physical evidence of a past civilization, its sand castle, is almost certainly lost. The chance of finding a preserved ruin, a skyscraper fossilized in rock, is so infinitesimally small as to be functionally zero. We are not looking for a city. The tide has washed it away. We are not even looking for a flattened mound of sand where the city once stood. The beach itself has been pulled into the sea. This forces us to accept a humbling truth. If we are to find anything, we cannot look for the thing itself. That has vanished. We must look for something far subtler, something that might just survive the long, slow wash of geological time, the faintest trace of a single, special grain of sand. To find even a single grain of that sandcastle, a fossil is a journey into the heart of improbability. We often think of fossils as common, filling our museums with the skeletons of dinosaurs and the beautiful spiral shells of ammonites. But this is a trick of perception, a form of survivor bias. We see the few who won the geological lottery, not the trillions upon trillions who vanished without a trace. The truth is, becoming a fossil is one of the rarest events in nature. The conditions must be perfect, a sequence of fortunate accidents that conspire to save a fleeting moment from the relentless tide of decay. Imagine, for a moment, a single creature. Let us say it is a small, forest-dwelling animal from 50 million years ago. For its story to reach us, a whole chain of unlikely events must occur. First, it must die in the right place. If it dies on an open plain or a mountainside, its body will be consumed by scavengers, its bones scattered and gnawed, and then ground into dust by the wind and the rain. Its story ends there. To have a chance, it must die in or near water, a quiet lake, a slow-moving river, or a swamp where it can be quickly buried by sediment. This is the crucial first step, a rapid, gentle burial that protects it from the elements and the hungry mouths of the world. Let us imagine our creature is lucky. It falls into a muddy river and is swiftly covered by a layer of silt. Now, the second challenge begins. The soft parts of its body, its skin, its muscles, its organs, will decay almost immediately, eaten by bacteria. Only the hard parts, the bones and teeth, have any real chance of surviving. And even they are fragile. The water seeping through the mud is often acidic, slowly dissolving the bones like sugar in tea. For our creature to survive, the chemistry of the water and sediment must be just right, neutral or alkaline, preserving the delicate structure of the bone. Even if the conditions are perfect, the process has only just begun. Over thousands and thousands of years, more and more layers of sediment must pile on top, increasing the pressure and temperature. The weight of this growing burden must be immense, but not so immense that it crushes the bones completely, as groundwater, rich with dissolved minerals, percolates through the layers. It begins to seep into the tiny porous spaces within the bones. Slowly, molecule by molecule, the original organic material is replaced by resilient minerals like silica or calcite. This is the magic of fossilization. The bone is not preserved. It is transformed, turned into a perfect stone replica of itself. Millions of years pass. The riverbed, now buried under a mountain of rock, is lifted up by the slow collision of continents. The rock is now exposed to the surface, where the forces of erosion begin their work anew. For us to find this fossil, it must be uncovered at just the right moment in human history, in a place where someone is looking, before it too is weathered away into dust. The window of opportunity for discovery might only be a few decades in a story that spans millions of years. What this really means is that for every single fossil we hold in our hands, countless millions of other creatures lived and died and vanished utterly. The fossil record is not a film of the past. It is a handful of random frames, torn and faded, from which we must try to guess the entire story. Now, consider a hypothetical industrial civilization. Where do its inhabitants live? Mostly on land, in cities, far from the gentle, sediment-rich environments needed for fossilization. Their remains would be subject to all the destructive forces we have described. The chances of one of them becoming a fossil are astronomically small. We are searching for a needle in a haystack, but the haystack is the size of a continent, and most of the hay has already burned. There's something quietly poetic about this idea. The very intelligence and mastery over the environment that defines a civilization makes its inhabitants less likely to be remembered by the planet. They build shelters that keep them from the elements, systems that dispose of their dead, and live in places not conducive to preservation. In a way, they write themselves out of the geological story. The sandcastle of their cities is gone, the bodies of its builders have returned to dust. So, we must accept that the direct evidence is lost to us. We must turn away from the search for a body, a bone, a tool. We must look for something else entirely, not the artifact, but its shadow. If the artifact is gone, and the fossil is a near impossibility, our search must undergo a profound change. We must stop looking for the object and start looking for its effect. We must shift our focus from a tangible physical piece of evidence to an intangible chemical trace left on the planet itself. We are no longer archaeologists, sifting through the dirt for a shard of pottery or a carved stone. We are becoming planetary detectives, looking for a faint fingerprint left on the entire global system. This broad planetary scale footprint of advanced technology is what scientists call a technosignature. It is the shadow that a civilization casts upon its world. Imagine you are standing in a silent, snow-covered forest. A deer has just walked through a clearing ahead of you. Now, it is gone, vanished into the dense woods. You cannot see the deer anymore. You cannot hear it, but you can see its tracks in the fresh snow, the pattern of the hoof prints, their depth, their spacing. They tell you a story. They speak of the deer's size, its speed, the direction it was headed. The tracks are not the deer, but they are undeniable evidence of its presence. They are its signature. A technosignature is like this, but on a planetary scale. A civilization is the deer, and the geological record is the field of snow. We are searching for the tracks it left behind during its brief walk across the clearing of time. What kind of tracks would an industrial civilization leave? They would not be as clear as hoofprints. They would be subtle, woven into the very fabric of the planet's chemistry. Consider the air we breathe. For billions of years, the Earth's atmosphere has been a slow, beautiful dance of natural cycles. Volcanoes release carbon dioxide, plants absorb it, life blooms and dies, and its elements are recycled. An industrial civilization, especially one that burns vast quantities of fossil fuels, would interrupt this dance. It would be like a new, powerful dancer suddenly leaping onto the stage, changing the rhythm and the flow for everyone. It would release vast amounts of carbon, nitrogen, and other chemicals into the air and water at a rate far faster than nature is accustomed to. This sudden burst of activity would leave a mark. These chemicals, circulating through the atmosphere and oceans, would eventually find their way into the sediments at the bottom of the sea and into the ice sheets at the poles. They would be laid down in a thin, distinct layer, a planetary track in the snow. A future scientist, millions of years from now, could drill down through those layers of rock or ice and read them like a timeline. They would see the slow, steady rhythm of the ages, and then, suddenly, a strange and abrupt spike in certain chemicals. That spike, that anomaly, that thin dark line in the strata, that would be the technosignature. What this really means is that a civilization's most enduring legacy might be its own waste. It's a humbling and rather poignant thought. The grand monuments, the soaring works of art, the profound philosophical texts, all of these turn to dust. But the invisible byproducts of the energy that powered that civilization, the exhaust from its engines and the runoff from its factories, these might be the things that last for geological time. The story of their existence would be told not by their poets, but by the subtle shifts in carbon isotopes and the unexpected presence of synthetic molecules in a layer of ancient mud. This changes our perspective entirely. We are no longer looking for a single lucky fossil. We are looking for a global signal, a whisper that was heard all around the planet at the same time. This is both a harder and an easier task. It is harder because the signal could be faint and easily confused with natural events. But it is easier because we don't need to find one specific lucky spot on Earth. We just need to find a good, clear record of Earth's history, a deep-sea core, an ancient slab of rock, and know how to read its language. To learn that language, however, we have only one dictionary, one Rosetta Stone. We must look at the only example of a technosignature we know for certain is being created. We have to look in the mirror. We have to study our own time, the Anthropocene. To learn how to read this faint, ancient language of a technosignature, we have only one living example to study. We must turn our gaze away from the deep past for a moment and look at the reflection in the mirror of the present. We must examine the footprint that we, humanity, are currently making upon the planet. Scientists have given a name to our current geological era, this time of unprecedented human influence, the Anthropocene, the age of humans. Looking at our own impact is not an exercise in judgment or anxiety. For our journey tonight, it is a purely practical act. It is like a detective studying a fresh set of tracks in the snow to understand how to spot older, fainter ones that have been weathered by time. The Anthropocene is our blueprint. It is our only guide to the kinds of signals a global, industrial civilization might leave behind in the rock. Imagine we are no longer on the Earth, but floating in space, far above it, watching the last few centuries unfold in a time-lapse. From this serene vantage point, we see the planet breathing. The great ice sheets at the poles pulse with the seasons, growing and shrinking. The vast green swathes of the rainforests darken and lighten with the rains. The planet is a living, dynamic system. Then, as our time-lapse enters the last few moments, the equivalent of the last 200 years, we begin to see new, rapid changes. At night, the dark continents begin to sparkle with vast interconnected webs of light, like new constellations being born on the surface of the Earth. We see the shapes of the forests change, with large areas receding like a green tide going out. We see the colour of the oceans near the coasts shift, as plumes of sediment from rivers and algae blooms change the water's hue. These are the visible signs, but the most significant changes are invisible to the naked eye. We would need special instruments to see them. If we could see the heat signature of the planet, we would notice a slow, steady warming. If we could see the chemical composition of the atmosphere, we would observe a haze of new gases beginning to accumulate, a subtle thickening of the airy blanket that cloaks the world. Carbon dioxide, methane, nitrous oxide, these molecules, while always present in small amounts, are now being added at a furious pace. This is the heart of our technosignature. We are fundamentally altering the chemistry of the planet's atmosphere and oceans. What this really means is that we are writing our own story into the geological record, right now, in real time. The excess carbon we release from burning fossil fuels will be recorded in the shells of sea creatures and buried in ocean sediments. The nitrogen from our fertilizers, washing down rivers, will alter the chemistry of the seabed. The tiny persistent particles of plastic we create will form a new and permanent layer in the strata. Even the novel radioactive isotopes from our nuclear activities, though small in quantity, have a half-life so long they will act as an unmistakable marker for millions of years to come. Future geologists, whether human or not, will be able to identify our era with startling precision. They won't need to find a single human fossil. They will simply see a thin, dark, and chemically bizarre line in the rock and know that something happened here. There's a quiet awe in this realization. We are living, breathing, and creating the very evidence we are searching for in the past. We are the sand castle at the peak of its construction, just as the tide is beginning to turn. By studying ourselves, we learn what to look for. We learn to search not for cities but for carbon isotopes, not for monuments but for nitrogen cycles, not for bones but for the chemical ghosts of plastic. The Anthropocene provides us with a checklist, a field guide to the past. It teaches us the questions we need to ask the rocks. And the first and most important question it teaches us to ask is about the planet's breath. The first and most significant track in our planetary field guide is woven into the very air. Imagine the Earth's carbon cycle as a slow, deep, and rhythmic breath, a process that has been happening for billions of years. In this great planetary respiration, the forests and the oceans inhale, drawing carbon dioxide out of the atmosphere. They use it to build life, the wood of trees, the shells of plankton, the very fabric of the living world. Then, just as slowly, they exhale. When living things decay, or when volcanoes erupt, that carbon is released back into the atmosphere. For eons, this breath has been remarkably steady, a slow and balanced exchange that keeps the planet's climate in a state of delicate equilibrium. It is the gentle, sleeping breath of a healthy, living world. An industrial civilization that discovers the immense energy locked away in fossil fuels fundamentally changes the rhythm of this breath. Fossil fuels, coal, oil, and natural gas are essentially buried sunlight. They are the concentrated remains of ancient life, vast forests and plankton blooms that inhaled carbon from the atmosphere hundreds of millions of years ago. That carbon was locked away, deep underground, taken out of the planet's breathing cycle and put into a kind of geological sleep, A civilization that learns to extract and burn these fuels is, in essence, finding this ancient stored breath and releasing it all at once. Imagine finding a vast underground chamber filled with the compressed air of 1,000,000 ancient sunsets. And then, over the course of just a few centuries, you open a valve and release it all back into the atmosphere. This is what we are doing. We are taking carbon that was slowly stored over 300 million years and releasing it in a sudden, sharp exhalation that lasts only a few hundred. On a geological timescale, this is not a breath, it is a cough, a sudden convulsive event that jolts the entire system. This is the first and most powerful technosignature we would look for. This sudden spike of carbon in the atmosphere would leave a clear and lasting fingerprint in the geological record. The key is in the type of carbon. Carbon comes in different varieties, or isotopes. Living things, like the plants that form fossil fuels, have a preference for a lighter isotope of carbon, called carbon-12. So, the carbon released from burning fossil fuels has a unique isotopic signature. It is unusually rich in this lighter carbon. A scientist drilling into ancient rock layers would analyze the carbon isotopes in each layer. For millions of years, they would see a steady natural ratio of heavy to light carbon. Then, in one thin layer, they would see a sudden dramatic shift, a huge influx of light carbon. This change would be unmistakable. It would be a chemical scream in the otherwise quiet library of the rock. The planet's breath would have suddenly changed its chemical signature, telling a story of something new and powerful and fast happening on the surface. What this really means is that the very energy source that powers a civilization's rise might also be the most permanent record of its existence. The same engine of progress becomes a geological pen, signing the civilization's name into the strata of the Earth. It's a beautiful and slightly ironic symmetry, and this signature would be truly global. The atmosphere mixes everything together, so this carbon spike would be recorded everywhere on the planet at the same time, in the rocks at the bottom of the Pacific Ocean, in the mountains of the Himalayas, in the ice of Antarctica. It's a single planetary scale event. It is the first and perhaps clearest track in the snow we are searching for. But it is not the only one. Our modern age is not just defined by what we burn, but also by what we make the strange new materials that may outlast even the memory of our carbon breath. Beyond the invisible signature of our breath, we are also creating a new kind of stone, a physical artifact so strange and so durable that it could become one of the most unambiguous fossils of our time. To understand this, let us take a journey not into the past, but into the distant future. Imagine standing on a beach 10 million years from now. The sky is a familiar blue, the sun is warm, and the waves crash upon the shore with the same timeless rhythm. The world looks pristine, wild, and untouched. The great cities of humanity are long gone, ground into dust and washed into the sea. The mountains have shifted, the coastlines have been redrawn. From all appearances, you are in a world that has no memory of what came before. You walk along the water's edge, looking at the smooth, rounded pebbles that the surf has tumbled for millennia. You see stones of granite, quartz, and basalt, in all their natural shades of grey, white, and black. But then, your eye catches something unusual. You reach down and pick up a strange-looking rock. It is partly made of familiar volcanic basalt, but fused into it are colourful, swirling veins of something else. Something that looks like melted, hardened plastic. It has an unnatural, manufactured quality. Embedded within this strange conglomerate, you can make out the ghostly outline of a bottle cap, the faded, shredded remnants of a plastic bag, and the hard, angular fragments of what was once a child's toy. This is a plastiglomerate, a genuine geological term for a new type of rock being formed in our era, as our plastic waste melts and fuses with natural materials like stone, sand, and shells. This strange hybrid rock is a fossil of our age. It is a direct, physical remnant of our material culture, but one that has been incorporated into the planet's own rock cycle. Plastics are polymers, long chains of molecules that do not exist in nature. They are incredibly resistant to decay. While a plastic bottle might break down into smaller and smaller pieces over centuries, The fundamental polymer chains can persist for millions of years, especially when buried in sediment, away from the damaging effects of sunlight and oxygen. What this really means is that our discarded waste, the things we use for a moment and then throw away, may outlast our greatest monuments. The pyramids of Giza are slowly eroding, the Great Wall of China is crumbling, but the plastic water bottle you drank from yesterday, if it finds its way into the geological record, could become a permanent part of the Earth's crust. Future geologists might define the start of the Anthropocene not by a change in carbon, but by the first appearance of these strange synthetic polymers in the rock strata. A layer of stone, found all over the world, suddenly filled with these bizarre, man-made molecules. There's a quiet, humbling poetry to this. We strive to leave a legacy through art, through stories, through magnificent buildings. But perhaps our most lasting legacy, the one that will be most clearly legible to the deep future, will be the mundane, disposable detritus of our daily lives. A plastic agglomerate is a message in a bottle, thrown into the ocean of geological time. It doesn't carry a story of our hopes or our dreams. It simply says, we were here, we made this, and we made a lot of it. The search for a past civilization, then, could involve looking for a similar layer of synthetic strangeness. A geologist in our time, drilling a core sample from an ancient seabed, might search for a layer containing complex polymers that have no business being there, a thin stratum of rock that whispers a story of a long-lost age of chemistry and convenience. But even stranger and more persistent than plastic is another, more ethereal trace we are leaving behind, a faint, warm glow that will linger in the rock for longer than almost anything else. Beyond the breath and the manufactured stone, there is a third, more subtle signature we are creating, one that is almost invisible, yet may be the longest lasting of them all. It is a faint warmth, a quiet hum in the rock, the radioactive afterlife of our atomic age. This trace is not about abundance, like carbon, or novelty, like plastic. It is about time itself. It is about creating atoms that are like clocks, ticking away for hundreds of millions of years, long after every other trace of our existence has faded. To understand this, we need to picture the heart of an atom. At its center is a nucleus, a dense cluster of protons and neutrons. In most of the atoms that make up our world, this nucleus is stable. It will remain as it is forever. But some atoms have unstable nuclei. They are out of balance. Over time, these unstable atoms will spontaneously decay, releasing a burst of energy and transforming into a different, more stable element. This process is called radioactivity, and the time it takes for half of a given sample of unstable atoms to decay is called its half-life. Some half-lives are very short, measured in seconds or days, but others are incredibly long, measured in thousands, millions, or even billions of years. Nature produces radioactive elements, of course. Uranium, for instance, has a half-life of over 4 billion years, but our civilization has learned how to create new, artificial radioactive elements or radioisotopes that do not typically exist on Earth. In the cores of our nuclear reactors and in the fire of our atomic weapons, we create elements like plutonium-239 with a half-life of 24,000 years, or curium-247 with a half-life of nearly 16 million years. Even more significantly, we have created isotopes like iodine-129 with a half-life of 15.7 million years and neptunium-237, which has a staggering half-life of over 2 million years. These man-made isotopes, even in the minuscule quantities we have created them, are a powerful technosignature. When released into the environment, they disperse globally, carried by wind and water currents, and eventually settle into the sediment. A future geologist, analysing a layer of rock corresponding to our time, might find these specific, unnatural isotopes. Finding even a few atoms of something like curium-247 would be like finding a perfectly machined screw in a layer of pristine, untouched wilderness. It is an undeniable sign of artifice, of a technology capable of manipulating the very core of matter. What this really means is that our brief, bright flash of nuclear technology has left a permanent, smouldering ember in the geological fireplace. The fire may be out, the civilization that lit it long gone, but this faint, radioactive warmth will continue to glow in the rock for a timescale that dwarfs human history. It's a signature of immense power and longevity. A spike of carbon might be explained away by a massive natural volcanic event. Strange polymers might, through some unknown chemistry, have a natural origin. But an isotope like plutonium-239 has no known natural pathway for its creation on Earth. Its presence would be a smoking gun, a nearly unambiguous signal of a past technological society. There is a profound sense of quiet responsibility in this idea. The power to create these long-lived atoms is the power to sign our name in the planet's eternal ledger. It is the most permanent mark we can make. So, as we search the past, we can now add this to our list. We listen for a sudden change in the planet's breath. We look for a strange synthetic stone. And we scan the rocks with a sensitive detector, searching for the faint, anomalous warmth of an atom that tells a story of a long-extinguished man-made fire. With these tools in hand, we can now turn our gaze back to the deep past and see if any moments in Earth's history look familiar, if any chapter in the geological library contains a story that rhymes with our own. Armed with our checklist of techno-signatures, a sudden carbon breath, a synthetic stratum, a radioactive glow, we can now begin our journey back into the deep archives of the Earth. We are no longer just guessing, we are searching for a specific pattern. And as we scan the geological record, one particular event stands out, a chapter in Earth's history so dramatic and so strangely familiar that it demands our attention. It is a time, 56 million years ago, known as the Paleocene-Eocene Thermal Maximum, or the PETM. For our purposes, we can think of it simply as a case study, a dress rehearsal for the Anthropocene, a planetary fever that happened long before humans ever walked the Earth. Imagine the world 56 million years ago. It was a very different place. The continents were still drifting toward their modern positions. The planet was already much warmer than it is today, a greenhouse world with no ice caps at the poles, and lush, subtropical forests stretching into the high latitudes. Alligators and palm trees thrived in the Arctic. It was a world already in a warm state, and then something happened. Geologically speaking, it happened in an instant. Over a period of just a few thousand years, a blink of an eye in geological time, the entire planet warmed by another 5 to 8 degrees Celsius. It was a sudden, violent spasm of heat, a global fever that lasted for about 200,000 years before the Earth system slowly returned to its previous state. When geologists first studied this event in the rock record, they found something startlingly familiar. They drilled deep into the ocean floor, extracting long, cylindrical cores of sediment that provide a continuous timeline of the past. As they analyzed the layers corresponding to the PETM, they found a massive, abrupt spike in light carbon isotopes. It was an unmistakable signal. A vast quantity of carbon, enriched in carbon-12, had been released into the atmosphere and oceans all at once. The planet, it seemed, had let out a great, sudden exhalation, just like the one we are creating today. The effects were profound. The oceans became more acidic, causing a mass extinction of tiny shelled organisms on the seafloor. The chemistry of the ocean changed so dramatically that for a time, these creatures could no longer form their shells, leaving a blank layer in the fossil record. On land, the sudden climate shift caused a huge migration of animals and a rapid evolution of new species, including the earliest primates, our own distant ancestors. The PETM was a pivotal, transformative moment in the story of life on Earth, and it was driven by a massive carbon release, the very first and most prominent technosignature on our list. What this really means is that we have found an event in Earth's past that looks, at first glance, uncannily like the footprint of an industrial civilization. It has the right chemical signature, the right global scale, and the right cascading consequences. For a moment, it feels like we have found a genuine candidate, a faint hum in the rock that resonates with our tuning fork. It's a tantalizing and mind-bending possibility. Could this have been them? A lost civilization from 56 million years ago, burning their own version of fossil fuels and triggering a planetary climate crisis? However, the deeper scientists have studied the PETM, the more complex the story becomes. The leading scientific explanation is that this carbon release was natural. Perhaps vast deposits of methane hydrates on the seafloor became unstable and erupted into the atmosphere. Or maybe massive volcanic activity, as the North Atlantic Ocean was first opening up, burned through immense deposits of ancient coal and oil, releasing their carbon. The PTM serves as a humbling lesson. It shows us that nature itself can create events that mimic the signature of civilization. The planet, on its own, can have a fever. The Earth can produce its own version of an industrial footprint. This makes our search infinitely more difficult. We are not just looking for a signal, we are looking for a signal that cannot be explained by any natural cause. The PETM is a perfect imposter, a natural event that puts on the mask of a technosignature. It reminds us that our checklist must be more rigorous, our clues more subtle. We need to look for other, corroborating fingerprints that a natural event wouldn't leave. We need to examine a different kind of global breath. The carbon spike of the PETM, so familiar and yet so deceiving, teaches us that we need a subtler clue, a second fingerprint to cross-reference with the first. We need a signature that points more specifically to industrial-scale activity, something less likely to be mimicked by volcanoes or erupting methane. This brings us to another of the planet's great cycles, a quieter and more complex breath than that of carbon, the nitrogen cycle. Nitrogen is the most abundant gas in our atmosphere, making up nearly 80% of the air you are breathing right now, but in its atmospheric form, it is aloof and unavailable to most living things. It must be fixed, its strong chemical bonds broken before it can be used to build proteins and DNA, the very molecules of life. For billions of years, this fixing of nitrogen was the patient work of specialized bacteria in the soil and the dramatic, fleeting energy of lightning strikes. These were the only two ways that atmospheric nitrogen could be converted into a usable form for the vast web of life. The amount of fixed nitrogen available was a fundamental bottleneck on life itself, a natural limit to how much could grow. A planet's biosphere, in a way, could only grow as fast as its bacteria and its thunderstorms could provide this essential nutrient. Then, in the early 20th century, two German chemists, Fritz Haber and Carl Bosch, developed a process that changed the world. They figured out how to use immense heat and pressure to fix nitrogen artificially, pulling it from the thin air and turning it into ammonia, the basis for synthetic fertilizers. The Haber-Bosch process effectively broke the natural bottleneck. For the first time, a single species humanity could create biologically available nitrogen on an industrial scale. This invention is arguably the most important of the modern era. It is the engine that has allowed our population to grow from just over 1 billion to 8 billion people. It is the chemical foundation of our global agricultural system. We are, in a very real sense, feeding our civilization with nitrogen pulled from the air. This incredible feat of chemistry leaves a distinct and global signature. The industrial process of creating fertilizer changes the natural ratio of nitrogen's own isotopes. Just like with carbon, there are heavier and lighter versions of nitrogen atoms. The synthetic nitrogen we produce has a unique isotopic fingerprint. When we spread these fertilizers on our fields, a significant amount of it eventually washes down our rivers and into the oceans. There, it is incorporated into the shells and bodies of marine organisms, which then die and fall to the seafloor, becoming part of the sedimentary record. What this really means is that our industrial-scale agriculture is writing a nitrogen signature into the geological strata, right alongside the carbon one. A future geologist would see not just a spike in light carbon, but at the very same time, a sudden and dramatic shift in nitrogen isotopes. This is a crucial second piece of evidence. A massive volcanic eruption might release a lot of carbon, but it wouldn't create a global spike of artificially fixed nitrogen. An eruption of methane hydrates wouldn't alter the nitrogen cycle in this specific way. The nitrogen fingerprint is a signature not just of energy use, but of large-scale, systematic agriculture, of a civilization consciously manipulating the planet's chemistry to feed a massive population. There's a quiet power in this idea. The evidence for a lost civilization might not lie in the ruins of its cities, but in the ghostly chemical echo of the bread they ate. It's a beautifully intimate trace, a story of how they sustained themselves, written in the mud of the deep ocean. So our search becomes more refined. We are no longer just looking for a fever. We are looking for a fever, accompanied by a global farming footprint. The two signals together would be a much stronger indication of a true technosignature. It's a quieter clue, but a far less ambiguous one. And it leads us to wonder about another profound way a civilization might change the face of its planet, not just by what it adds to the air, but by what it takes away from the land. Beyond the invisible signatures in the air and water, a global civilization leaves a much more visible mark, a scar on the very skin of the planet. To see it, let us once again float in orbit, high above the Earth, watching the continents drift by below. From this serene vantage point, we can see the planet's great green heartlands, the vast, deep emerald of the Amazon, the Congo, and the rainforests of Southeast Asia. These are the ancient forests, the lungs of our world, ecosystems that have existed in a state of dynamic balance for millions of years. Now, as we watch in our time-lapse, we see a profound change. The deep, solid green begins to fragment. Brown patches like sores appear and grow. The sharp, straight lines of roads and settlements cut through the wild, organic shapes of the forest. The green tide is going out. This is the scar of deforestation. A civilization with a large population and a need for resources for agriculture, for building materials, for fuel, will inevitably clear vast areas of forest. This process, when it reaches a global scale, leaves a distinct mark in the geological record, a signature written not in chemistry, but in simple, physical sediment. An ancient, undisturbed forest is a master of self-preservation. Its dense canopy of leaves intercepts the rain, softening its impact. Its intricate network of roots, a subterranean web of life, clutches the soil, holding it in place. The forest floor, thick with decaying leaves and organic matter, acts like a sponge, absorbing water and releasing it slowly. A healthy forest holds onto its land with a powerful living grip. When that forest is cleared, this protective skin is removed. The soil is left naked and vulnerable. When the rains come now, they strike the ground with their full force. There are no leaves to soften the blow, no roots to hold the soil together. The water runs off in muddy torrents, carrying away the topsoil in a process called erosion. Rivers that once ran clear now run brown, thick with the lifeblood of the land. This sediment, this lost soil, doesn't just disappear, it is carried downstream out into the estuaries and the oceans. There, in the calmer waters of the continental shelves and the deep sea, this sediment settles out, raining down onto the ocean floor. Over thousands of years, this creates a new, distinct layer of rock. A geologist drilling a core from this area would see a sudden and dramatic change in the record. For millennia, the sediment layers might be thin, composed mostly of the fine-grained skeletons of marine organisms. Then, abruptly, the record would change to a thick, coarse layer of terrestrial sediment, the signature of a massive erosion event. The very substance of the rock would change, telling a story of a time when the land was suddenly and violently washed into the sea. What this really means is that the memory of a lost forest might be better preserved at the bottom of the ocean than on the land where it once grew. The scar of deforestation is written in the deep, and this signature, when combined with our others, paints an even clearer picture. A carbon spike could be a volcano, a nitrogen spike is a stronger clue. But a carbon and nitrogen spike, happening at the exact same time as a massive global pulse of land, erosion showing up in oceanic sediments worldwide, that becomes a very compelling case. It tells a story of a civilization clearing its forests, fertilizing its fields, and powering its industries, all at once. It's a convergence of evidence, a story told in 3 different languages, air, water, and earth, all saying the same thing. This brings us to a quiet and rather profound turning point in our search. We have been building a case for how to find a civilization much like our own, one that is industrial, expansionist, and leaves a heavy, perhaps messy footprint on the planet. But this line of thinking leads us to a fascinating and deeply humbling paradox. What if a civilization was not like ours? What if it was truly advanced, truly wise? What would its footprint look like then? As we build our toolkit for detection, focusing on the scars and fevers of a planet, we quietly stumble upon a profound and humbling paradox. We have been learning to look for the signature of a civilization that is, in many ways, young and inefficient. We are looking for the geological echo of a society in its energetic adolescence, burning through its inheritance of fossil fuels, clearing its lands with haste, and leaking its waste into the air and sea. All of our proposed technosignatures, the carbon spike, the nitrogen footprint, the erosion scar, are signs not just of technology, but of a technology that has a large disruptive impact on its planet. This leads us to a simple yet world-altering question. What if a truly advanced civilization would leave no trace at all? Imagine a civilization that has matured. It has survived its own adolescence and has learned to live in a state of dynamic equilibrium with its planet. Perhaps they mastered sustainable energy sources early in their history. They might have skipped a fossil fuel phase entirely, drawing their power directly from their star or from the geothermal heat of their world's core, or perhaps from some form of clean fusion we can only dream of. Their energy systems would be closed loops, producing no waste, leaving no chemical signature in the atmosphere. Their breath would be indistinguishable from the natural, sleeping breath of their planet. Their material science, too, might be perfectly circular. Instead of creating persistent synthetic polymers like our plastics, they might build with materials that are intelligently designed to decompose, to return to their constituent elements, to be endlessly recycled by the biosphere. Their cities would not be built of concrete and steel, but might be living structures, woven from genetically engineered wood that heals itself, purifies the air, and at the end of its life, melts back into the soil. Their agriculture would not be a system of industrial monoculture, leaking nitrogen into the oceans, but a perfectly integrated form of permaculture, working in harmony with the local ecosystem, enriching the soil rather than depleting it. This civilization, in its wisdom and its technological grace, would be almost invisible to geology. They would be a ghost, not because time had erased them, but because they had learned to walk so softly on their world that they left no tracks in the snow. They would have achieved a kind of technological transcendence, becoming a seamless part of their planet's metabolism rather than a disruptive force. From a geological perspective, their long and successful history would look like nothing at all. Just another stretch of quiet, balanced planetary life. What this really means is that our search for a past civilization might be fundamentally biased. We are looking for a society that made the same mistakes we are making. We are searching for the echo of our own industrial clamour, but a civilization that was quieter, wiser, and more sustainable would be a whisper in the geological library, a book written in invisible ink. The very act of becoming a long-term, stable presence on a planet might be the act of erasing your own technosignature. Success, in this context, means becoming undetectable. This is the paradox of sustainability. The civilizations most likely to survive for vast stretches of geological time, the ones who truly master their technology and their relationship with their planet, might be the very ones that are impossible to find in the deep past. We might only be able to find the ones that failed, the ones that burned brightly and briefly before sputtering out, leaving behind a telltale layer of ash and ruin in the rock. This thought is not a dead end for our journey, it is an invitation to deepen it. It asks us to quiet our minds and imagine what such a green and ghostly civilization might have looked like, and how they might have written their story not in scars, but in whispers. Let us linger for a moment in this quiet, contemplative space created by the paradox of sustainability. Let us try to imagine this other kind of world, this green civilization that walks so lightly upon the earth. To find them, we must adjust our senses, tuning them away from the loud signals of carbon and waste, and instead listen for the faintest, most harmonious of whispers. We are no longer looking for a geological fever, but for a sign of profound and lasting health. Picture a city in this hypothetical world. It does not stand apart from nature, a stark grid of stone and metal against a green landscape. Instead, it is woven into it, almost indistinguishable from it. The buildings are not towering skyscrapers that scrape the clouds, but are perhaps grown like great, engineered banyan trees, their living walls filtering the air and water, their leaves capturing sunlight and turning it into energy with near-perfect efficiency. Walkways spiral through these structures like vines, and the sound is not of machines and traffic, but of wind in the leaves and flowing water, channeled through the city's circulatory system to cool and cleanse. This city does not consume the forest. It is a forest of a different, more conscious kind. The inhabitants of this world would not have seen a distinction between technology and nature. To them, they would have been one and the same. Their mastery of genetics and biology would have been their primary form of engineering. Imagine them travelling not in machines of metal, but perhaps in symbiotic biological vessels, gliding through the air or sea with the silent grace of a manta ray. Their tools would not be forged in fire, but grown in nutrient baths, designed to be reabsorbed by the ecosystem when their purpose was served. There would be no concept of waste, only of resources in transition, of nutrients in a constant flowing cycle. This was a civilization that understood the deep, slow rhythms of the planet, because they saw themselves as a part of it, not as its master. Their science and their spirituality would have likely been intertwined, both rooted in a profound reverence for the intricate, interconnected web of life. Their grandest projects would not have been pyramids or monuments to individual rulers, but perhaps vast, continent-spanning ecological restorations, the patient healing of a damaged landscape, or the subtle tuning of the climate to maintain a state of perfect balance. Their legacy would be written in the health of the soil, the purity of the oceans, and the sheer, dazzling biodiversity of their world. What would such a civilization leave behind for us to find, millions of years later? Almost nothing that we have been looking for. Their energy use would leave no carbon spike. Their agriculture, no nitrogen signature. Their cities, no plastic agglomerates. But they might leave a different kind of trace, a UBO signature, a signature of good, healthy life. Perhaps a geologist might notice, in a specific geological era, an unusually high rate of biodiversity in the fossil record, or a strange and sudden flourishing of complex ecological relationships that seem too stable, too resilient to be entirely natural. Maybe they would find evidence of a planetary climate that remained inexplicably stable for millions of years, defying the usual cycles of ice ages and warm periods. What this really means is that the ultimate techno-signature might be a signature of harmony. The greatest sign of intelligence might be the evidence of a planet that has been gently and lovingly tended like a garden. This is a far more difficult search, a search for a subtle and beautiful signal instead of a loud and messy one. We would be listening not for a cough, but for a perfectly steady, sleeping breath. And yet, this vision of a green civilization, so elusive to our geological tools, is not a discouragement. It is a source of quiet inspiration. It offers a glimpse of a possible future, a reminder of what a mature relationship with a planet might look like. Even if we cannot find their traces in the past, the mere act of imagining them might help us to shape our own. But our search is not over. There is one place, one final archive, where even the faintest whispers might be preserved. We must go down, deep down, into the planet's silent memory. Our search for a whisper, for the faint echo of a green civilization, or the faintest chemical trace of an industrial one, leads us away from the churning, chaotic, the surface of the world. We must journey to the most stable, most silent, and most pristine archive on the entire planet, the bottom of the deep ocean. Imagine letting go of the bright sunlit world and beginning a slow, peaceful descent into the abyss. The vibrant blue of the surface waters gradually deepens to a rich indigo, then to a soft, perpetual twilight. The pressure builds, a gentle, insistent embrace from the immense weight of the water above. The sounds of the surface world fade away, replaced by a profound and all-encompassing silence. Down, down you drift, past the strange bioluminescent creatures that flicker in the dark like lonely stars, their brief lives the only light in this timeless realm. Finally, you come to rest on the abyssal plain, thousands of meters below the surface. Here, the world is still. The water is just a few degrees above freezing. The currents are slow and languid, like the breathing of a sleeping giant. Time itself seems to move differently here, measured not in days or years, but in millennia. The seafloor is a vast, undulating blanket of fine, soft sediment, the accumulated dust of ages. For millions of years, a slow, gentle rain has been falling through the water column. This marine snow is a constant, quiet blizzard of tiny particles. The microscopic shells of plankton, the fine grains of wind-blown dust from distant continents, the ash from faraway volcanoes, and the cosmic dust from passing comets. Everything that is in the air and the surface water eventually finds its way down to this final resting place. This is the Earth's ultimate memory bank. Unlike the land, which is constantly being eroded, uplifted, and recycled, the deep sea floor is a place of accumulation. The layers of sediment build up, one on top of the other, in an almost perfectly undisturbed sequence. Each layer is a page in the planet's diary, capturing a snapshot of the world's chemistry and climate from the moment it was laid down. To drill a core from this deep sediment is to pull a perfect, continuous record of history up into the light. It is the closest thing we have to a time machine. If a past civilization existed, this is where its most subtle chemical whispers would be preserved. A sudden spike in carbon from their fossil fuels would be locked away in the chemistry of the tiny fossil shells. The unique nitrogen isotopes from their fertilizers would be there. Any strange, persistent synthetic molecules, even in parts per trillion, might be trapped in the fine clay. The long-lived radioisotopes from their nuclear technology would be present, a faint warmth against the cold background. The deep ocean is a patient and meticulous librarian, collecting and filing away every trace, no matter how small. What this really means is that the truth may not be written in the grand ruins of continents, but in the microscopic fossils of the abyss. The story of a global civilization would be an epic told by the tiniest of creatures. The ocean does not remember cities or symphonies, but it remembers the composition of the air and the temperature of the water with perfect fidelity. It is an incorruptible witness. So, our search now has a focus. We must go to this quiet, dark place and listen. We must learn to read the faint chemical signals embedded in this ancient mud, searching for a single layer that tells a story of a world that was, for a brief time, different. This deep, cold archive of the ocean floor holds the history of the water and the air that touched it. But there is another archive, just as pristine, that holds the memory of the atmosphere itself, trapped in a different kind of frozen stillness. We must travel from the deepest dark to the brightest white, to the great ice sheets at the poles of the Earth. Our journey now takes us from the crushing pressure of the deep sea to the brittle, crystalline cold of the planet's poles. We leave behind the dark, liquid archive and arrive in a world of blinding white, a vast, silent expanse of ice that stretches to the horizon in every direction. We are in Antarctica, or perhaps Greenland, standing on an ice sheet over 3 kilometers thick. The air is so cold it feels sharp in your lungs, and the silence is so profound it seems to have a weight, broken only by the faint whisper of the wind and the soft crunch of your boots on the snow. This immense frozen shield is another of the Earth's great libraries, and its books are written in the most delicate of inks, bubbles of ancient air. Imagine the process that builds this library. Each year, a fresh layer of snow falls upon the ice sheet. As the snow deepens, the weight of the new layers above compresses the old layers below. The fluffy, six-sided snowflakes are squeezed together, their delicate arms breaking and reforming, slowly transforming into dense, granular ice. In this process, tiny pockets of the surrounding atmosphere are trapped between the ice crystals. As the compression continues, these pockets are sealed off, becoming perfect, tiny bubbles, little glass spheres holding a pristine sample of the air from the year that snow fell. Layer by layer, year by year, century by century, the ice sheet grows, entombing a perfect chronological record of the Earth's atmosphere. To read this record, scientists drill deep into the ice, extracting long cylindrical cores, just as they do from the ocean floor. When they bring a section of this ice core into the light, it is like holding a piece of frozen time. You can see the annual layers, sometimes as clear as tree rings, and suspended within the crystal clear ice are the tiny silvery bubbles, the ghosts of ancient air. In a laboratory, these bubbles can be carefully opened, and the air inside can be analysed. Scientists can measure, with incredible precision, the exact concentration of carbon dioxide, methane, and other gases from 100,000 years ago, or 800,000 years ago. It is like listening to the Earth's breath, recorded on a crystal-clear medium. An ice core is a direct atmospheric archive. It does not just tell us about the air indirectly, through the chemistry of the ocean. It gives us the air itself. If an industrial civilization existed during the lifetime of these great ice sheets within the last few million years, its atmospheric signature would be captured here, with breathtaking clarity. We would see its carbon breath, not as an isotopic echo in a fossil shell, but as a direct measurement of increased Cot2-inch, the bubbles. We could search for traces of industrial pollutants, synthetic gases that have no natural source, trapped in these tiny, frozen time capsules. What this really means is that the polar ice is a witness. It has been silently observing and recording the story of the sky for ages. The secrets of the past are not locked away in a vault. They are simply frozen, waiting for us to ask the right questions. So, the search for a lost civilization within the recent geological past, the last few ice ages, could be as simple and as difficult as drilling in the right place and analysing the ancient air. We would be looking for a single anomalous breath in a record of 1 million quiet breaths. So far, in the ice cores we have drilled, which take us back nearly 1 million years, we have found no such anomalous breath, other than our own, which will be preserved for the future. The record shows the natural rhythmic cycles of the ice ages, the slow, deep breathing of the planet, but no sudden industrial coughs from a forgotten era. This does not mean our search is over. The ice sheets are a recent library, but they provide a powerful tool and a powerful constraint. They also point us toward a secondary effect, another subtle clue we can now look for in the archives of the ocean, a story told not by what is present, but by what is suddenly, mysteriously absent. The sudden exhalation of carbon into the atmosphere, whether from a natural event like the PETM or a hypothetical industrial civilization, does more than just warm the planet. It triggers a second, quieter crisis in the world's oceans, a change in the very chemistry of the water. This leads us to a new kind of signature, a subtle and rather melancholy clue. We are no longer looking for the presence of something strange, but for the sudden absence of something familiar. We are looking for a ghost layer in the rock, a chapter in the geological library where the main characters suddenly disappear without a trace. To understand this, imagine the surface of the ocean, teeming with life. Among the most abundant and important creatures are the foraminifera, tiny, single-celled organisms, most no bigger than a grain of sand. They are a crucial part of the marine food web, but for our purposes, their most important feature is that they build beautiful, intricate shells around themselves, usually made of calcium carbonate, the same mineral that makes up chalk and limestone. They are microscopic architects, patiently constructing their tiny chambered homes from the minerals dissolved in the seawater. When these organisms die, their resilient little shells drift down through the water column, a constant, gentle rain of calcium carbonate, settling on the seafloor. For hundreds of millions of years, this process has built up thick layers of chalk and limestone, a physical record of the life that once filled the oceans. Now, picture what happens when a massive amount of carbon dioxide is released into the atmosphere. A large portion of this CO2 is absorbed by the oceans. When carbon dioxide dissolves in water, it forms carbonic acid. It is a weak acid, but when you add trillions of tons of it to the ocean, it begins to lower the water's overall pH, making it more acidic. This is ocean acidification. For the tiny foraminifera, this is a catastrophe. In more acidic water, the calcium carbonate they need to build their shells becomes much harder to form. The very building blocks of their homes begin to dissolve around them. Imagine being a mason, trying to build a house with bricks that are crumbling to dust in your hands. This is the crisis the foraminifera face. As ocean acidity rises, they struggle to build their shells. Many die. Many more are born with shells that are thin and weak. In a severe acidification event, an entire generation of these creatures might be wiped out, or their delicate shells might dissolve completely before they can ever reach the seafloor and become part of the geological record. This creates the ghost layer. A geologist drilling a core from the seabed would see the evidence clearly. For meters and meters, the core would be filled with the familiar chalky fossils of foraminifera. Then, in one distinct layer corresponding to the carbon spike, they would simply vanish. The rock would change, becoming a dark, clay-rich layer, empty of the tiny white shells. It would be a silent, empty page in the book of life. This is called a forum gap. After the event, as the ocean chemistry slowly rebalanced over thousands of years, the foraminifera would gradually return, and their fossils would reappear in the layers above. What this really means is that a key piece of evidence for a global catastrophe might be a story of absence. The silence in the rock can be as loud as a chemical scream. The PETM, our natural case study, shows a prominent forum gap, a clear sign of ocean acidification. Any industrial civilization that powered itself on fossil fuels would almost certainly leave behind this same melancholy signature. It is a profound and poignant trace, a memorial to the unseen victims of a changing world, their microscopic bodies erased from the memory of the stone. So we add this to our search. We look for a time when the planet's breath changed, its fields were unnaturally fertilized, its land washed into the sea, and for a brief sad moment, the tiny architects of the ocean forgot how to build their homes. But even with all these clues, the Earth has one more lesson in humility to teach us. A reminder that nature's ingenuity can sometimes look just like our own. As we refine our list of technosignatures, growing more confident in our ability to distinguish an artificial signal from a natural one, the Earth presents us with a story so improbable, so perfectly confounding, that it serves as a final, humbling reminder of the limits of our knowledge. It is a story of a time when nature, on its own, built a nuclear reactor. This is not a thought experiment or a metaphor. It is a geological fact. The discovery takes us to a place called Oklo, in the nation of Gabon in West Africa, and it pushes our timeline back not millions, but billions of years. The story begins in 1972, at a French nuclear fuel processing plant. A scientist was conducting a routine analysis of uranium ore that had been mined from the Oklo site. He noticed something strange. The uranium ore contained a slightly lower concentration of a specific isotope, uranium-235, than it should have. All uranium found anywhere else on Earth, or in meteorites, or on the Moon, has a consistent, predictable ratio of its isotopes. But this ore from Oklo was anomalous. It was as if someone had already used it, as if it had been burned in a reactor. The discrepancy was tiny but unmistakable. An investigation was launched, tracing the ore back to its source, and what the geologists and physicists found there rewrote our understanding of what is possible in the natural world. They discovered that nearly 2 billion years ago, in what is now Gabon, a series of natural spontaneous nuclear fission reactors had formed and operated in the Earth's crust. The conditions, by a sheer cosmic coincidence, had been perfect. First, back then, the concentration of the fissile uranium-235 isotope in natural uranium was much higher, about 3%, which is similar to the level required in modern man-made reactors. Over the last 2 billion years, much of it has naturally decayed, which is why the concentration is lower today. Second, a rich vein of this uranium ore was saturated with groundwater, which acted as a neutron moderator, a substance needed to slow down the neutrons and sustain a chain reaction. So, deep underground, a pocket of uranium-rich rock became so saturated with water that a chain reaction began. The reaction generated immense heat, which boiled the groundwater away. Without the water to moderate the neutrons, the reaction stopped. As the rock cooled, groundwater seeped back in, and the reaction started up again. For hundreds of thousands of years, this natural reactor pulsed, turning on and off in a gentle, self-regulating cycle. It generated heat, it consumed its fuel, and it produced the same kinds of nuclear waste products, like specific isotopes of xenon and neodymium, that a modern reactor does. The geologists at Oklo found these waste products still trapped in the surrounding rock, the final, undeniable proof of what had happened. What this really means is that even the most advanced and seemingly unambiguous technosignature on our list, the presence of unusual radioisotopes, can be created by nature. The Earth, in its deep past, figured out how to build a nuclear reactor long before we did. The Oklo phenomenon is a beautiful and stunning example of nature's deceptive power. It creates a false positive of the highest order. If a future geologist without knowledge of Oklo were to find the isotopic signatures in that rock, they might conclude they had found the remains of a 2-billion-year-old nuclear-powered civilization. This doesn't invalidate our search, but it deepens it with a profound sense of caution. It tells us that no single piece of evidence is enough. A carbon spike could be a volcano, a forum gap could be a natural acidification event, even the byproducts of nuclear fission could be a geological fluke of cosmic proportions. To build a true case for a lost civilization, we would need not one, but all of these signals, and more, all happening in the same thin layer of rock, a convergence of anomalies so extreme and so interconnected that it would defy any natural explanation we could imagine. Having now fully explored the how of our search, we can finally allow ourselves to drift into the more speculative and wondrous question of who. What kind of a being, what shape of a forgotten mind, might have lived on this planet before us? Having spent so long in the quiet, meticulous world of geology and chemistry, searching for the faint traces of a lost world, we can now allow our minds to drift into a more imaginative space. Let us set aside the hard data for a little while and simply wonder, if a civilization did exist in the deep past, who were they? What was the shape of their minds, the form of their bodies? The whimsical name of our hypothesis, the Silurian, playfully suggests a reptilian intelligence, but the possibilities are as wide and as deep as the history of life on Earth. To contemplate this, we must first let go of our own reflection. We must understand that an intelligent being from a different geological era would likely bear no resemblance to us at all. Evolution is not a straight line, leading inevitably to humanity. It is a vast, branching tree, a constant exploration of countless different forms and solutions. We are but one tiny twig on one small branch of this immense tree. A civilization could have arisen from any other branch. Imagine, for instance, a world where the dinosaurs did not perish 66 million years ago. In a world dominated by reptiles for tens of millions of years more, intelligence might have arisen from a saurian lineage. What would a being evolved from a small, clever dinosaur look like? It might have skin of scales, not hair, and eyes that see the world in a different spectrum of light. Its mind, shaped by a reptilian brain, might be more patient, more attuned to the slow, cold-blooded rhythms of life. Their society, their art, their philosophy, all of it would be coloured by a biology utterly alien to our own. Or perhaps we should look to the insects. They are one of the oldest and most successful groups of animals on the planet. They mastered flight, complex social structures, and chemical communication hundreds of millions of years before us. What if intelligence had sparked within a communal hive-like species? A civilization of insectoids might not value the individual in the same way we do. Their consciousness could be more collective, a shared network of minds working in perfect, selfless harmony for the good of the hive. Their cities might be vast, humming, subterranean warrens, and their technology might be based on biological secretion and intricate, woven materials rather than forged metal. Their understanding of the universe would be shaped by a completely different sensory world, one of scent, vibration, and 1,000 tiny compound eyes. We could even imagine an intelligence that never left the ocean. The octopus and its relatives show a stunning level of intelligence, with complex problem-solving abilities and a nervous system that is profoundly decentralized. An aquatic civilization of cephalopods would be a creature of pure fluidity and grace. Their world would be three-dimensional in a way we land dwellers can barely comprehend. Their cities might be sculpted coral reefs or intricate structures built on the deep ocean floor. Their language could be a complex dance of color and light, their skin rippling with patterns that convey meaning and emotion in an instant. They would have no need for fire, the technology that shaped our own path so deeply. Their science would have followed a completely different trajectory, perhaps mastering pressure, genetics, and bioluminescence instead of combustion and electronics. What this really means is that the Parmen face of our predecessor is a perfect and beautiful mystery. To search for them is to acknowledge that our own form, our own way of thinking, is just one possibility out of a near-infinite spectrum. They could have been reptilian, insectoid, aquatic, or something we cannot even begin to imagine, a creature of silicon perhaps, or a vast intelligent fungus living beneath the forest floor. Each possibility opens a door in the mind, a new way of seeing our own planet. The only thing we can be reasonably sure of is that the world they inhabited, the very stage on which their story unfolded, would have been a profoundly different place from the one we know today. To truly imagine this forgotten civilization, we must imagine not just a different actor, but a completely different stage. The Earth itself has not been a constant. It has passed through a series of alien, almost mythical landscapes. The planet we inhabit today, with its familiar continents, its green grasses, and its abundance of flowers, is just a recent snapshot in a very long and dramatic film. To visit a civilization in a different geological era would be to step into a world with a different sky, a different air, and a completely different palette of life. Let us travel back in time, past the age of the dinosaurs, to the Carboniferous period, around 300 million years ago. If a civilization had arisen then, it would have been born into a world of vast, steamy global swamps. The air was thick and humid, heavy with nearly 50% more oxygen than we have today. This oxygen-rich atmosphere fueled a world of giants. The forests were not made of the trees we know, but of colossal ferns, towering club mosses, and 100-foot-tall lycopod trees with scaly diamond-patterned bark. There were no flowers anywhere on Earth. No birds sang in the branches. The world was a panorama of deep, silent greens and murky browns. The creatures of this world were like something from a dream. Dragonflies with the wingspan of a hawk flitted through the misty air. Millipedes the length of a human being crawled through the damp undergrowth. Giant amphibious creatures, halfway between salamanders and crocodiles, lurked in the dark, stagnant waters. A civilization born here would have known a world of perpetual twilight under the dense canopy of the swamp forests. Their engineering would have had to contend with the soft, unstable ground. Perhaps they built their cities on great, floating platforms, or high in the branches of the giant alien trees. The abundance of oxygen would have made fire a terrifyingly volatile force, a constant, explosive danger. Their technology might have avoided combustion altogether, relying instead on biochemistry or the strange electrical properties of the humid air. Now, let us journey to a different time, the Cretaceous period, the last age of the dinosaurs. Here, the world is warmer, and for the first time, a revolutionary new form of life is spreading across the land, the flower. For the first time, the planet is decorated with splashes of colour reds, yellows and purples. The air is filled with the buzz of new kinds of insects, bees and butterflies, co-evolving with these new flowering plants. An intelligent species here would have been the first to experience the scent of a blossom, the first to witness the changing colours of the seasons in this new and vibrant way. They would have shared their world with Triceratops and Tyrannosaurus rex, colossal forces of nature that would have shaped their architecture, their culture, and their deepest myths. What this really means is that any prior civilization would have been profoundly shaped by its environment in ways we can barely fathom. Their relationship with the planet would have been entirely different. Their senses would have been attuned to a different set of sights, sounds, and smells. The very chemistry of the air they breathed and the water they drank would have been different. The story of the life on Earth is not a single play, but a vast repertory theatre, with countless different productions staged over the eons. The Silurian Hypothesis invites us to imagine that one of these other productions, on one of these alien stages, also featured a cast of intelligent actors. Contemplating this possibility does not just create a sense of scientific curiosity, it evokes a much deeper, more personal feeling, a strange and complex emotional echo from the abyss of time. As we drift deeper into this thought experiment, moving from the tangible world of rocks and isotopes into the speculative realm of forgotten minds and alien landscapes, we might notice a subtle shift in our own feelings. The search for a past civilization is not just an intellectual exercise, it stirs something much older and more profound within us. The feeling that arises is not one of fear, of uncovering some terrible secret from the past. It is something quieter, softer, and more complex. It is a strange and poignant sense of loneliness, mixed with the equally profound and comforting idea that we may not be the first to feel that loneliness on this planet. Imagine standing on a deserted beach, the one where we watch the sandcastle disappear, but this time you notice a single faint footprint in the wet sand, not your own. It is faded, half erased by the last wave, but it is there. You have no idea who made it, where they came from, or where they went. You are still alone, but the knowledge that someone else stood right here, perhaps only a few moments ago, changes the quality of the solitude. The emptiness feels less absolute. It becomes a shared emptiness, a space that holds the echo of another presence. The feeling the Silurian Hypothesis evokes is like this, but stretched across an ocean of millions of years. There is a deep, instinctual human desire to not be alone, to be part of a larger story. We look to the stars for this connection, hoping to find a signal from another world. But this hypothesis turns that search inward. It suggests that the dialogue we seek might not be with a distant star, but with a deep and silent past, right here, at home. The silence from the stars is a vast, cold and empty silence. The silence from the geological record is different. It is a warm, earthy silence, a quietness filled with the ghosts of 1 trillion lives, a silence that might just hold the faint, resonant hum of another mind. This idea creates a new kind of kinship, a strange fellowship with the unknown. To imagine another civilization grappling with the same fundamental questions we do of meaning, of purpose, of their place in the cosmos, is to feel a sense of connection across the abyss of time. Did they look up at the same moon and wonder? Did they develop philosophies, create art, and struggle with the challenges of living together on a finite planet? Did they feel the same quiet awe when contemplating the universe? To even ask these questions is to build a fragile, imaginary bridge to them. What this really means is that the Silurian Hypothesis is as much a journey into our own emotional landscape as it is into the Earth's geological one. It touches on our deepest fears of insignificance and our deepest hopes for connection. It reframes our own story. If we are not the first, then our achievements are not a singular, unprecedented peak of complexity on this planet, but perhaps a recurring pattern, a beautiful and fleeting rhyme in the long poem of the Earth. Our struggles, our triumphs, and even our potential failures might not be unique. The path we are on might be a well-trodden one. This realization is not diminishing. It is, in its own way, deeply comforting. It places us within a grander tradition, a cycle of intelligence that may be a natural expression of the planet itself. And this idea, that our fate might be part of a larger pattern, brings our journey to a new and fascinating intersection, the place where the deep past of our own planet touches the vast cosmic search for life in the universe. Our quiet terrestrial search for a lost footprint in the sand now leads us, unexpectedly, back to the vast starry ocean of the cosmos. The Silurian Hypothesis, while focused on the Earth, provides a strange and intimate new lens through which to view one of the most profound and persistent questions we have ever asked. If the universe is so vast, why is it so silent? This question is the heart of the Fermi paradox, named after the physicist Enrico Fermi, who, during a casual lunchtime conversation, is said to have asked, "Where is everybody?" His point was simple. The universe is incredibly old and contains a staggering number of stars and planets. Statistically, intelligent life should have arisen countless times. Some of those civilizations should have become interstellar, so why do we see no evidence of them? No radio signals, no giant alien artifacts, no signs of life anywhere but here. The silence is deafening, and scientists have proposed many possible solutions. One of the most famous and sober concepts is the Great Filter. The idea is that there is some evolutionary or technological hurdle, some immense challenge that is so difficult to overcome that almost no civilization ever survives it. This filter could be anywhere on the timeline of life. Perhaps the jump from non-life to life is incredibly rare. Perhaps the evolution of complex multicellular organisms is the filter. Or perhaps the filter lies ahead of us, the challenge of surviving our own technological adolescence, of not destroying ourselves with the very power that defines our intelligence. The Silurian Hypothesis brings this vast cosmic concept crashing down to Earth. It places a potential great filter not in the stars, but right here on our doorstep, buried in our own planetary history. It suggests that the lifetime of a technologically advanced civilization might be inherently, tragically, brief. A civilization might discover industrialization, burn through its fossil fuels, alter its planet's climate, and then collapse under the weight of its own success, all within a few thousand years. Geologically, this is a flash of lightning in a long, dark night. They would rise and fall in the blink of a geological eye, leaving behind only the faintest of chemical scars. If this is the case, then the reason the universe seems silent is not because intelligence is rare, but because it is fleeting. Imagine the history of a galaxy as a vast, dark forest stretching over billions of years. Once every million years or so, a single tree in that forest lights up with the fire of a technological civilization. It burns brightly for a few moments, a glorious incandescent beacon in the dark. But then, just as quickly, it burns out, leaving only a bit of charcoal and a faint memory of the light. The forest is, on average, always dark and silent, not because there is no fire, but because the fires never last long enough to spread from tree to tree. The lighthouses are blinking, but they are blinking across such vast gulfs of time that they are destined to never see one another's light. What this really means is that the Great Filter might be a planetary one. The challenge of creating a truly sustainable, long-term civilization, one that can survive for millions of years, might be the hardest challenge in the universe. It might be that the laws of planetary science and the dynamics of civilizations are such that most cultures simply don't make it. They leave behind a thin layer of strange chemistry in the rock of their home world, a quiet testament to their brief and brilliant moment in the sun. This thought transforms the geological record into something more than just a history of the Earth. It becomes a potential graveyard of these failed attempts, a cosmic case study written in our own backyard. The search for a past civilization on Earth is, in this light, a search for a fallen sibling, a predecessor who may have faced the same filter we are now approaching, and their legacy, if it exists, would not be written in statues or poems, but in the very substance of the stone itself. This brings us to a quiet redefinition of one of our most cherished concepts, the idea of a legacy. When we think of leaving a legacy, our minds turn to things of permanence and purpose. We think of the great pyramids of Egypt, enduring monuments of stone that have carried a story across millennia. We think of the epic poems of Homer or the philosophical dialogues of Plato, ideas written on fragile papyrus that have outlasted empires. We think of art, of music, of laws, of institutions, the intricate and beautiful structures we build to give our lives meaning and to project that meaning into the future. We strive to leave a mark that says, "We were here, and this is what we valued." The Silurian Hypothesis, however, invites us to consider a legacy of a completely different kind. It is a legacy stripped of all intent, all artistry, all meaning. It is a legacy that is purely, profoundly physical. If a civilization rose and fell millions of years ago, its entire existence, its dreams, its struggles, its grandest creations would be compressed by the immense, indifferent pressure of geological time into a single, thin layer of rock. Imagine a future geologist, 1 billion years from now, examining a cliff face. They see thick, regular bands of limestone and shale, the slow, patient story of ordinary times. But then, their eye is drawn to one anomalous stratum, a dark line, perhaps only a few inches thick, sandwiched between the mundane layers above and below. To an untrained eye, it is just another line in the rock, but to this geologist, it is a library. Within that thin band, they find a sudden spike in a rare isotope of carbon. They detect the fossilized molecules of complex, unnatural polymers. They measure a faint, lingering radioactivity from an element with no natural origin. They see a layer of mud washed in from the land and a ghostly absence of the tiny shells that should be there. This thin layer of unusual clay is the civilization's final monument. It is their pyramid, their epic poem, their entire history, all condensed into a silent chemical scream. It does not speak of their hopes or their fears. It does not record the names of their kings or the wisdom of their philosophers. It simply records the raw physical fact of their global impact. It is a testament not to their minds, but to their metabolism. It is the fossil of their entire technological body, their technosphere. What this really means is that a civilization's ultimate legacy might be an unintentional one. It is the byproduct of their existence, the waste from their energy, the ghost of their footprint. It is a message with no author and no intended recipient, a simple statement of planetary scale cause and effect. There is a deep and humbling poetry in this. It suggests that the universe remembers chemistry and physics with far greater fidelity than it remembers history or art. The laws of nature are the final scribes, and they write their story in the universal language of atoms and isotopes. This perspective doesn't diminish the value of our own art or philosophy. It simply places it in a grander, more humbling context. The things we build for ourselves for meaning are for the fleeting timescale of our own lives. The mark we leave on the planet is for the deep, eternal timescale of the Earth, and as we stand here, in our own time, creating our own anomalous layer, we are faced with a profound choice. We are actively writing our own legacy in the stone. The question is not whether we will leave a mark, but what that mark will say. This reframes our place in the cosmos, and it forces us to reconsider the very nature of our solitude. The vast, silent backdrop of the cosmos has always invited us to ask a simple, profound question. Are we alone? For centuries, this question has pointed our gaze outward, toward the shimmering veil of the Milky Way, searching for a kindred spark in the stellar wilderness. We have listened for their voices with our radio telescopes and scanned distant atmospheres for the chemical breath of their worlds. In this outward search, the silence has felt like an answer, a quiet, resounding yes, suggesting that we are a singular, improbable miracle in a sterile universe. But the Silurian Hypothesis takes this same question and gently turns it on its head. It suggests that perhaps we have been asking the wrong question all along. Maybe the issue isn't whether we are alone, but whether we are simply lonely. Imagine for a moment that intelligence is not a rare cosmic fluke, but a common recurring product of a living planet. Imagine that on billions of worlds across the galaxy, and perhaps many times on our own, life has given rise to a thinking, tool-making species. The universe, in this view, is not empty and sterile, but is in fact teeming with the potential for civilization. The silence we perceive is not the silence of an empty house, but the silence of a house where everyone is sleeping in a different room, at a different time. The great distances between the stars are one barrier, but the Silurian Hypothesis introduces a second, equally vast barrier, the deep, silent distances of time. Let's return to our image of the lighthouses blinking in the dark. A civilization is a brief flash of light. It might last for 10,000 years, or 50,000, or even 100,000. But in the life of a planet that is billions of years old, this is a mere instant. The time between these flashes, the long, quiet epochs of ordinary non-technological life, can last for tens of millions of years. The chances of two civilizations on the same planet existing at the same time are almost zero. The chances of two civilizations on neighboring stars existing at the same time to be able to communicate across the light years becomes even more vanishingly small. So, we might live in a universe that is fundamentally full of life and intelligence, but we are destined to experience it as empty. Our solitude would be an illusion, a trick of cosmic timing. We are not alone, but we are isolated by the immense, unbridgeable gulfs of time. This is a loneliness of a different kind. It is not the desolation of being the only one, but the poignant, melancholy feeling of having just missed the party, or of knowing that another will begin long after you are gone. What this really means is that intelligence may not be a destination, but a season. It is a brief, vibrant summer that a planet can experience, before the long, quiet autumn and the deep, frozen winter returns. The planet itself continues, its biological heart beating steadily, but the brief fever of technological consciousness fades. This perspective is both comforting and deeply sad. It is comforting because it suggests we are part of a natural, perhaps universal pattern. It is sad because it implies that the dialogue we seek, the connection we crave, is fundamentally impossible. We can only ever talk to ourselves and listen to the faint geological echoes of those who came before. This reframing of our solitude offers a new sense of purpose. If we cannot speak to our contemporaries across the stars, perhaps we can try to speak to our successors across the eons. We can become conscious of the story we are writing into the rock. We can think of ourselves not as the sole authors of this planet's intelligent story, but as one chapter in a much longer book. And this leads us to see the Earth itself in a new light, not as a passive stage for our drama, but as an active participant, a single, interconnected system with a life and a memory of its own. As we contemplate the idea of civilizations as fleeting seasonal blooms, our perspective of the Earth itself begins to shift. We start to see it less as a simple backdrop of rock and water, and more as a single, cohesive entity, a vast, interconnected system with its own rhythms, its own feedback loops, and perhaps its own form of planetary memory. This leads us to another gentle but profound scientific idea, the Gaia Hypothesis. Proposed in the 1972 by James Lovelock and Lynn Margulis, it suggests that we can view the Earth's entire biosphere, all of its life, from the smallest bacterium to the largest whale, along with its atmosphere, oceans, and soil, as a single, self-regulating organism. Imagine you are floating in space again, looking down at the blue marble of our world. From this distance, you don't see individual creatures, you see vast, integrated systems. You see the Amazon rainforest acting as a great lung, breathing in carbon dioxide and breathing out oxygen, creating its own rainfall and regulating the climate of an entire continent. You see the microscopic plankton in the oceans, producing a chemical that seeds clouds in the atmosphere, subtly influencing the planet's reflectivity and temperature. Every part is connected to every other part in a delicate, intricate dance that has maintained the conditions for life on this planet for over 3 billion years. In this view, the Earth is not just a rock with life on it. The life and the rock have evolved together, shaping each other, creating a planetary-scale body that actively maintains its own health. Now, into this ancient, balanced Gaian system, introduce a new phenomenon, a technosphere. A technosphere is the global, interconnected structure of a technological civilization. It is the sum total of our cities, our factories, our power grids, our farms, our satellites, and our digital networks. It is a new, planetary-scale layer, a kind of global metabolism, but one that operates on a much faster, more energetic, and more disruptive frequency than the slow, patient cycles of the biosphere. The technosphere consumes energy and resources at a furious rate, and it produces novel waste products that the biosphere has never seen before and does not know how to recycle. From the perspective of the Gaia hypothesis, a technosphere is like a new, rapidly growing organ in the planetary body. The question is this new organ a beneficial symbiont, a neutral passenger, or a dangerous, cancerous growth? A young, inefficient technosphere, like our own, acts as a powerful, destabilizing force. It disrupts the ancient established cycles of carbon, nitrogen, and water. It triggers a planetary fever, a climate change, as the Gaian system struggles to adjust to this new energetic presence. The Earth, as a single organism, is trying to rebalance itself in the face of a powerful internal shock. What this really means is that a great filter might not be an external event like an asteroid impact, but an internal immunological response from the planet itself. A civilization might rise and create a technosphere so disruptive that it triggers feedback loops in the planetary system that make its own survival impossible. The planet, in its effort to heal itself and return to a stable state, might simply shake off the civilization that caused the fever. It's not a conscious or malicious act, but a simple, systemic rebalancing. The Earth organism would survive, but the fleeting, feverish consciousness that sparked on its surface would be extinguished. This perspective gives us a new and powerful metaphor for sustainability. To survive long-term, a civilization must learn to integrate its technosphere with the biosphere. It must transform its planetary organ from a cancerous one into a symbiotic one. It must learn to think like the planet, to work with its ancient rhythms rather than against them. It must become a mature, integrated part of Gaia. And if a past civilization failed to do this, the evidence of that failure would be written in the story of the Earth's slow, patient, and inexorable recovery. Let us imagine for a moment that such a civilization existed and that it failed. It burned brightly for its allotted few thousand years, creating a powerful technosphere that destabilized the planet's ancient systems. Then, for whatever reason, a climate crisis, a resource collapse, a failure of imagination, it flickered and died out. The hum of its machines ceased, its lights went out. The fleeting, conscious spark vanished from the surface of the planet. What happens next? The story does not end there. A new, much slower, and more patient story begins. The story of the Earth's recovery. The planet has a deep, quiet, and inexorable capacity for healing. It operates on a timescale that is almost impossible for us to comprehend, a timescale on which mountains rise and fall like slow-motion breaths. In the immediate aftermath of the civilization's collapse, its great cities would begin to crumble. Without constant maintenance, steel rusts, concrete cracks, and buildings fall. Nature, with its patient, relentless force, would begin to reclaim the land. Vines would snake through the ruins, their tendrils breaking apart stone. Seeds carried by the wind would take root in the dust-filled streets, and over a few centuries the sharp geometric lines of the cities would soften under a blanket of green. In 1,000 years they would be little more than strange tree-covered hills. Meanwhile, the planet's great chemical cycles would begin the slow work of rebalancing. The excess carbon in the atmosphere, the cause of the planetary fever, would gradually be reabsorbed. The oceans would soak up a vast amount of it, though at the cost of their own acidity. The new, vigorous growth of forests on the abandoned continents would draw down more, locking it away in the wood and soil. Over tens of thousands of years, geological processes, like the weathering of rock, would scrub the rest of the carbon from the air, slowly and patiently pulling the planet's thermostat back down. The fever would break. The strange synthetic materials of the civilization would meet a similar, slow fate. Plastics on the surface, exposed to sunlight, would break down and become part of the soil. The more resilient polymers, buried in sediment, would remain, waiting to become the strange fossils we have imagined. The nitrogen that had saturated the rivers and oceans would be consumed by bacteria and returned to the atmosphere. The most stubborn traces, the long-lived radioisotopes, would remain in the rock, their faint warmth ticking away like a forgotten clock. But their influence on the living world would be gone. Over 1 million years, the planet would be profoundly transformed. The ice caps, if they had melted, might begin to reform. Species that had been driven to the brink of extinction would either vanish completely or radiate out into the newly available ecological niches, evolving into new forms. The coastlines would shift. The climate would settle into a new, stable rhythm. From the surface, the planet would look wild, pristine, and utterly untouched. The scar of the technosphere would be almost completely healed, its memory erased from the living biosphere. The only evidence of its existence would be that thin, anomalous layer buried deep under new layers of sediment, a secret kept by the stone. What this really means is that the Earth is the ultimate victor in any contest with a civilization. Its patience is deeper, its forces are greater. It has the power to absorb even the most violent of technological spasms, and, given enough time, to gently and completely erase the evidence from its surface. The planet does not forget, for the memory is in the rock, but it does heal. It moves on. This vision of a world after a forgotten collapse is not a tragic one. It is a story of immense and quiet resilience. It is a testament to the enduring power of life and the deep, slow pulse of the planet itself. And seeing this, seeing our own potential story from this vast geological perspective, provides us with a profound and unexpected message. As our long, winding journey through deep time begins to circle back toward the present, we arrive at a place of quiet reflection. We began with a search for another, a lost civilization buried in the rock. We learned how to look for their chemical breath, their synthetic fossils, their radioactive glow. We imagined their alien forms and the strange, forgotten worlds they might have inhabited. We stood in awe of the Earth's power to erase their story and heal itself. And in all of this, searching for a ghost in the past, we have come to realize that we have been looking into a mirror all along. The Silurian Hypothesis is not really about finding them, it is about finding ourselves. The entire thought experiment, every geological marker, every chemical signature, every imagined scenario, is a profound and elaborate tool for seeing our own civilization from a new and desperately needed perspective. It is a way of stepping outside of our own frantic, human-centered timescale and viewing our present moment through the long, slow, and patient lens of geological time. It takes the story of our impact on the planet, a story we usually tell with charts and graphs and anxious headlines, and transforms it into a deep, quiet, and timeless myth. By asking, what would they have left behind? We are forced to ask, in the most concrete terms possible, what are we leaving behind? The search for a carbon spike in the past makes us exquisitely aware of the carbon spike we are creating right now. The thought of a plastiglomerate fossil from a lost world makes us see the plastic bottle in our hand with new eyes, not as a piece of trash to be forgotten in a day, but as a potential geological artifact, a message to the far future. The concept of a great filter, brought down from the cosmos to the Earth, reframes our contemporary global challenges, climate change, biodiversity loss, resource depletion, not as political or economic problems, but as a great, perhaps final, evolutionary test. What this really means is that the message in the rock is for us. Whether or not a past civilization ever existed is, in the end, almost irrelevant. The true value of the hypothesis is the wisdom it imparts. It is a humbling story. It tells us that we are not the masters of this planet, but are a fleeting, fragile, and utterly dependent part of its ancient and complex system. It is a cautionary story. It shows us the shape of a failed planetary experiment, a path that a civilization can take that leads to a brief, bright flash, followed by a long silence. But it is also a story of hope. It implicitly contains the image of a different kind of civilization, the green, sustainable one, the one that learned to walk so lightly that it left no scars, the one that became a whisper of harmony instead of a scream of disruption. The Silurian Hypothesis, in its gentle, meditative way, gives us a new sense of our place in time. It connects us to the immense, silent story of the Earth, making us feel like a part of something far grander and more ancient than our own brief history. It gives us a sense of kinship, not just with the other life on the planet today, but with the entire 4 billion-year saga of life that came before us, and perhaps with any other intelligent life that might have been a part of that story. And most importantly, it brings our focus back, with startling clarity, to the here and now, to the profound significance of our own moment in the Anthropocene. Our journey has taken us across vast, imaginary oceans of time, but now, in these final moments, it delivers us back to the present, to the very room in which you are resting. As you lie here, breathing in and out, you are participating in the creation of the very layer we have been searching for all night. We are living inside the technosignature. The Anthropocene is not an abstract concept for future geologists. It is the warm, electric, and chemically altered reality of right now. We are the ones writing our chapter into the great stone library of the Earth, and the ink is still wet. Think of the air you are breathing. It contains a higher concentration of carbon dioxide than it has at any point in the last 800,000 years, a fact we know from the tiny bubbles of ancient air trapped in the ice cores we have journeyed to. Each breath you take, each breath every human being takes, is part of this new atmospheric story. The light from the lamp in your room, powered by electricity that likely came from burning fossil fuels, is a tiny individual contribution to the global carbon breath of our civilization. It is a quiet, mundane, and yet geologically significant act. Consider the objects around you, the soft fabric of your blankets, perhaps made of synthetic polymers. The plastic casing of the device on which you are listening to this story. These are the materials of our age, the novel artifacts that have no precedent in the planet's long history. Right now, at this very moment, countless tons of these materials are making their way into the world's sediments, beginning their long, slow journey to becoming the plastiglomerates of a future era. We are creating our own fossil record, not with our bones but with our belongings. Even the food we have eaten today plays a part. The global agricultural system that sustains us, powered by the industrially fixed nitrogen of the Haber-Bosch process, is steadily writing its unique isotopic signature into the world's oceans as we speak. The echo of our daily bread will be legible in the mud of the deep sea for millions of years to come. We are, in a very literal sense, eating our way into the geological record. What this really means is that we are not separate from the deep, slow story of the Earth. We are the authors of its newest and most dramatic chapter. This realization doesn't need to be a source of anxiety. Instead, it can be a source of profound and quiet mindfulness. It elevates our daily lives from a series of fleeting personal moments into a collective act of geological significance. It gives a new weight and a new meaning to our presence here. We are not just living on the Earth, we are actively and powerfully living in its history. This is our moment. This is our thin layer of rock in the making. The Anthropocene is the brief bright flash of our own civilization's fire, and we are the ones tending it. We are living at the precise moment of creation for a future geological mystery. And with this awareness comes not a burden, but a quiet and perhaps beautiful sense of responsibility for the kind of footprint we choose to leave behind. To realize that we are living within the creation of a geological stratum is to be handed a quiet and profound sense of purpose. It is to understand that our civilization's story will be told, whether we intend it to be or not. The choice before us is not whether to leave a mark, but what the nature of that mark will be. This awareness, born from our long journey into the past, is the essence of planetary stewardship. It is the shift from being an unconscious force of nature to a conscious, mindful, and responsible presence on our world. Imagine a painter standing before a vast, empty canvas. For a long time, the painter has been mixing colours and cleaning brushes, making a mess on the floor, unaware of the canvas itself. Then, suddenly, they look up and realize that every stray drop of paint, every careless smudge, has become a part of the final painting. This is the moment we are in. We have awakened to the canvas. We are now aware that our actions, both big and small, are contributing to the masterpiece or the mess that will be our legacy in the rock. The feeling this inspires is not one of guilt for the smudges already made, but a newfound intentionality about the strokes we are about to make. What kind of story do we want our layer to tell a future geologist? Do we want it to be a story of a brief, chaotic, and self-destructive flash? A story of a planetary fever, a mass extinction, and a sudden, sad silence? A classic example of a great filter, a civilization that reached for the stars but stumbled on its own doorstep? This is one possible narrative, the one told by the dramatic spikes and the ghost layers we have discussed. It would be a cautionary tale, written in the universal language of chemistry. Or do we want our layer to tell a different, more surprising story? Could our stratum record a moment of profound transition? Imagine a future geologist examining our layer. They would see the dramatic spike in carbon, the plastics, the nitrogen, all the signs of a young industrial civilization. But then, they might see something unexpected. They might see the carbon spike level off, and then, slowly, begin to decline. They might see the novel polymers become less abundant, replaced by new biodegradable materials that leave no trace. They might see the signs of mass deforestation reverse, as evidence of global reforestation begins to appear in the pollen record. This would be a remarkable story. It would be the story of a civilization that saw the edge of the cliff and chose to turn back. It would be the geological signature of a species achieving a new kind of consciousness, a planetary-scale wisdom. It would be the story of a fever that broke, not because the patient died, but because the patient healed itself. It would be the first known example in the planet's history of a species consciously and deliberately managing its own technosphere to bring it into harmony with the biosphere. What this really means is that our responsibility is to write a better story. The Anthropocene can be a tragic final chapter, or it can be the most dramatic and hopeful turning point in the entire 4-billion-year history of life on Earth. We have the unique privilege and the immense burden of living within that turning point. Every choice we make toward sustainability, toward balance, toward a lighter footprint is a brushstroke in that more beautiful painting. It is an act of writing a legacy of hope into the silent, patient memory of the stone. This transforms our view of the Earth itself, from a simple resource to be consumed into the precious archive that we are tending for all of time. And so, let us return to where our journey began, to the entrance of that vast and silent library of the Earth. When we first stepped inside, the air felt heavy with loss. We saw the collapsed shelves, the crumbled pages, the vast, empty gaps in the story of life. We were archaeologists of a ruin, sifting through dust and echoes, keenly aware of all that had been forgotten. But now, as we stand at its entrance once more, having journeyed through its deepest archives and contemplated our own place within its walls, the feeling is entirely different. The library no longer feels like a place of absence. It feels like a place of profound and unending creation. The cool, mineral scent of the ancient stone is the same, but now it smells not of decay but of patient potential. The deep silence is still here, but it is not an empty silence. It is the quiet of a grand scriptorium, the respectful hush of a place where a great and important story is still being written. The gaps on the shelves, the missing chapters, no longer seem like tragic losses. We now understand them as part of the library's own life cycle. The Earth is a library that is constantly editing, revising, and rebinding itself. The melting of a tectonic plate is not the burning of a book, but the recycling of its pages into a new, blank canvas. The slow erosion of a mountain range is the library, gently, patiently, turning a page. When we first walked these halls, we were visitors, outsiders looking for a story that was not our own. Now, we see the truth. We are not just visitors to this library. We are its current authors. Our civilization, the Anthropocene, is a single fresh page being inserted into this vast and ancient book, right now, in this very moment. The ink is the carbon in our atmosphere, the polymers in our oceans, the nitrogen in our soil. The paper is the thin layer of sediment that is forming day by day at the bottom of the sea and in the beds of our quiet lakes. We are writing our verse in the planet's long and epic poem. What this really means is that our legacy is not something we will one day leave behind. It is something we are already woven into. We are not separate from the deep history of the Earth. We are its newest, most turbulent, and perhaps most interesting expression. Our story does not stand alone. It is bound together with the story of the first cyanobacteria that breathed oxygen into the sky, with the story of the great fern forests of the Carboniferous, with the story of the dinosaurs, and with the story of the great ice ages that sculpted the land. Each was a chapter that profoundly changed the world and set the stage for the next. Now, it is our turn to write. There is a deep sense of belonging in this realization. We are not an accident, an unnatural plague upon the planet. We are a part of its narrative, a consequence of its 4 billion-year evolutionary journey. The Library of Earth is not just a record of the past, it is a living, breathing story, and we are at its writing edge. This changes our search. It is no longer a desperate hunt for answers about a forgotten other. It has become a quiet, mindful participation in our own story, and we begin to find peace, not in the discovery of a lost chapter, but in the profound beauty of all that remains unseen. As our journey finds its gentle, closing rhythm, we arrive at a place of quiet acceptance. We began with a question, a search for a definitive answer, a hope of finding a clear signal in the noise. But the deeper that we have travelled, the more the answer itself has seemed to dissolve, leaving behind something far more precious, a profound and lasting sense of wonder. The true gift of the Silurian Hypothesis is not a discovery, but a perspective. It is the ability to find a quiet and satisfying peace in the act of not knowing. Imagine you are standing on the shore of a vast, misty lake at dawn. You know that on the other side of the lake there is another shore, perhaps even another town, but the thick, swirling fog obscures your view. You can't see it. You can't hear it. You can only see the mist, the gentle lapping of the water at your feet, and the soft grey light of the morning. You could spend all your energy trying to pierce the fog, straining your eyes for a glimpse of the other side, feeling frustrated by the mystery. Or you could simply stand there, on your own shore, and appreciate the beauty of the scene before you, the ethereal quality of the mist, the cool air on your skin, the profound stillness of the world. The beauty of the unseen shore is that it allows the near shore to become more vivid, more present, more real. This is the peace that our journey offers. We may never know if another civilization shared this planet with us. The geological fog may be too thick, the evidence too faint, the tide of time too powerful. But the act of looking for them has made our own world, our own moment, infinitely more precious. It has allowed us to see the ground beneath our feet not as inert dirt but as a sacred archive. It has allowed us to see our own civilization not as a mundane reality, but as a geological miracle, a fleeting and beautiful sandcastle on a cosmic shore. What this really means is that the mystery itself is the treasure. The unanswered question is a beautiful open space in which our imagination can wander and our sense of awe can grow. It connects us to the great, silent, and unfolding story of the cosmos in a way that a simple, factual answer never could. To know for certain would be to close the book. To live with the question is to be forever invited to turn the page, to wonder, to dream. There is a deep and meditative calm in this. It is the release of the need for certainty. It is the gentle embrace of the magnificent ambiguity of our existence. We do not need to find a fossil of a forgotten intelligence to feel a sense of connection to the deep past. We can feel it in the layered rock of a cliff face, in the smooth coolness of a river stone, in the silent, steady breathing of the earth itself. The absence of evidence is not the evidence of absence, but an invitation to listen more closely, to look more deeply, and to appreciate the profound and beautiful story that is happening right here, right now. And this grand, cosmic perspective ultimately leads us back to a feeling of incredible and liberating smallness. As we zoom out for our final view, let our perspective expand one last time, pulling away from the Earth, past the Moon, past the glowing planets, until our entire solar system is just a spark in the river of the Milky Way. From this immense, silent distance, we can hold the entire 4.5 billion-year story of our planet in the palm of our hand. It is a single, beautiful, swirling marble of blue and white. Now, on this cosmic scale, let us try to locate our own history, the entire span of recorded human civilization, from the first clay tablets to the present moment. On this planetary timescale, our whole story, all of our triumphs and tragedies, our art and our science, is less than the blink of an eye. It is a single, impossibly thin layer of dust on the surface of that marble. Now, let us imagine the full, glorious sweep of human existence, from our earliest tool-making ancestors to whatever distant future we might have. Even that grand story is just a fleeting moment in the life of the Earth. Let us try to picture it. Go to a vast ancient beach, a beach that has seen 1,000,000 beach tides. Reach down and pick up a single grain of sand. Hold it in your fingers. Feel its tiny, granular texture. This single grain of sand, against the backdrop of all the sand on all the beaches of the world, is the timescale of our entire species. And the story of a hypothetical past civilization would be another single grain of sand, perhaps lost somewhere on a different continent, in a different time. This perspective is not meant to be diminishing. It is not meant to make us feel insignificant or small in a negative way. On the contrary, it is meant to be liberating. To see our lives, and even our entire species, as a brief and beautiful flicker in an immense ancient universe is to be freed from a certain kind of cosmic pressure. It is to understand that we are not the sole protagonists of the universe's only story. We are a brief, beautiful, and utterly improbable part of a much grander, much older, and much more mysterious saga. What this really means is that our single grain of sand is a miracle. The fact that we are here at all, on this particular world, at this particular time, able to hold this awareness, to ask these questions, and to feel this sense of awe, is the most profound wonder of all. Our smallness does not negate our meaning. It is the very source of it. We are the universe's brief, fleeting opportunity to look at itself, to wonder about its own past, and to dream about its future. There is a deep and abiding peace in this. It is the peace of letting go of our own cosmic importance and simply accepting our place in the grand, flowing river of time. We are a note in a symphony that is billions of years long. We do not need to be the whole symphony. It is enough, more than enough, to simply be a note, to sound our brief, clear tone in the immense and beautiful silence. And so, our long and wondrous journey ends not with a clamour of discovery, but with a new and profound appreciation for the beauty of that silence, and a new way of listening to its faintest whispers. And so, at the very end of our journey, we arrive at a place of pure listening. We have quieted our minds, we have set aside our frantic search for artifacts and answers, and we have let go of our need for certainty. All that is left to do is to be still and to listen. We are not listening for a voice, a signal, or a message. We are listening to the silence itself, a silence that is now filled with a new and profound resonance. It is the silence of deep time, the quiet, patient hum of a planet that has seen ages come and go like the turning of the tides. Imagine you are lying in a vast open field at night. The air is cool and still. The sky above is a boundless canopy of stars, a silent, glittering spectacle that has unfolded just like this for eons. At first, the silence might feel empty, but as you lie there, your senses begin to adjust. You start to hear the gentle, rustling whisper of the grass in the slightest of breezes. You hear the impossibly distant, lonely call of an owl. You hear the faint, rhythmic chirp of a single cricket. The silence is not empty at all. It is layered. It is textured. It is full of a deep and subtle life. This is how we now listen to the geological record. We are no longer straining to hear a shout. We are attuning our ears to the faintest of whispers. We are listening to the slow, grinding music of the tectonic plates, the patient, the percussive drip of water forming a cave, the almost inaudible sigh of sediment settling on the deep ocean floor. These are the rhythms of the Earth's own long and quiet song, and within that song, we are listening for a single, anomalous note, a faint, chemical dissonance that might tell the story of another singer who once stood where we stand now. What this really means is that our entire journey has been a form of meditation. It has been a practice of calming the noisy, insistent voice of the present moment so that we can begin to perceive the vast, quiet presence of the past. It has been an exercise in expanding our sense of self beyond our own lives, beyond our own species, to feel a sense of kinship with the very rocks and waters of the world. The silence we are listening to is not outside of us. It is within us. The iron in our blood, the calcium in our bones, the salt in our tears, all of it was forged in the hearts of long-dead stars and has cycled through this planet's living systems for billions of years. We are made of the same dust as the mountains and the same water as the ancient oceans. We are a part of the silence. To listen to this silence is to find our true home, not in a particular country or a particular time, but in the grand, unfolding story of the cosmos, right here on this small, precious planet. It is to know that even if we are the only ones, we are part of a story so vast and so beautiful that it is more than enough. And if we are not the only ones, if there was another, then our listening connects us to them. Our quiet act of wondering becomes a silent, one-sided conversation across a gulf of 1,000,000 years, a shared moment of awe in the face of the same immense and beautiful mystery. And that is a profound and peaceful place to be, as you let your own quiet breath join the slow, steady, sleeping breath of the world. Our long journey is now drawing to a close. We began tonight in the comfort of our own time, asking a simple question that seemed to point toward a distant and alien past. Where did that question lead us? It took us down, deep into the patient archives of the Earth, through layers of rock and ice that hold the planet's quiet memory. We searched for the footprints of a lost civilization, a sudden breath of carbon in the ancient air, a strange stone made of unnatural materials, a faint, radioactive warmth that might linger for 1,000,000 years. We sought a ghost in the geological machine. We found no lost cities. We unearthed no strange fossils. The deep silence of the Earth did not yield a clear and unambiguous voice from its past. But our journey was far from fruitless. We discovered something else, something quieter and perhaps more profound. We discovered a new sense of our own place in the immense, unfolding story of this planet. The search for another civilization became a journey of self-discovery, holding up a geological mirror to our own time, our own Anthropocene. We learned to see our world not as a permanent stage, but as a constantly changing canvas, a library that is forever rewriting itself. We imagined other minds, other forms, born under other skies, and in doing so, we felt a strange and poignant kinship with them across the unfathomable gulfs of time. We saw that a civilization's greatest legacy might not be its monuments or its art, but the unintentional chemical shadow it casts upon its world. We found not an answer, but a deeper, more resonant question. And so, we returned to where we began, but changed. The question, what if we are not the first, no longer hangs in the air as a puzzle to be solved. It now rests gently within us, as a source of quiet wonder, a meditative lens through which to see the world. It has taught us to listen to the silence of the rocks, to feel the immense patience of the earth, and to appreciate the fragile, fleeting, and miraculous nature of our own conscious moment. We found no definitive proof of another, but we found a deeper connection to the one home we know, and a quiet, humbling peace in the great, beautiful mystery of it all. As you drift now, let that quiet peace be the soft ground that holds you. Let the slow, deep rhythm of geological time be the gentle tide that carries you into a peaceful and restorative sleep.